In this video, we will discuss a variety of transformations, including translations, rotations, reflections, and dilations. Early on, we learned these 7 basic rules that are worth memorizing. So, you need to pause the video and memorize these if you have not already done so. So problem number 1, after a transformation, the point a 4, -5 is transformed into a prime 5, -4. In other words, we went from 4, -5 to 5, -4. So let's analyze this in terms of a general point x, y, so we can get at the rule. So let's see. Ignoring the signs, I see a 4 and a 5, and then I see a 5 and a 4. So the x and y have definitely switched places. So let's get that into the rule. So we will definitely have a y and an x. The order changes. Now let's see, what about the signs? The x value 4 became -4. So the sign of the x value changed, and we will indicate that with a little negative sign. What about the y value? Okay, the y value went from -5 to +5, so the y value sign changed as well. So that gives us the rule xy becomes -y, -x. So if you've memorized the rules, you can think back and ask yourself which one of these transformations takes you from xy to -y, -x. And you will recall that that's what happens when you do a reflection over the line y equals -x. So that's why the answer is A. You should always use capital letters when you do a multiple choice test, because some of your lowercase b's look a lot like uppercase D's and things like that. If you put this on the line, is that a B or a D? I don't know. Some of you intentionally put something like this if you're not sure if the answer is B or D. So you'll try to make the teacher guess. You know, maybe they'll give you the benefit of the doubt. But I solve all that by having you use uppercase letters. Alright, anyway, problem number 2. I digress. Which of these rules would stretch a figure vertically? Well, so that means 2 things. A stretch is only going to affect either the x or the y, not both. A vertical stretch, that means we're talking about y values. Okay, because the y value controls the vertical motion. So right away we know it's not going to be A or B, because that's the x value is affected. That would be horizontally. So it's between C and D. And stretch, that means that it's getting taller. Okay, it's going from this to this. So that's going to happen if you multiply by something that is greater than 1. So they're both fractions, but only one of these fractions is greater than 1, and that's D. So the answer is D. And I'm hoping that it's obvious that 5/4 is greater than 1. See how it's an improper fraction with the larger number in the numerator, whereas 4/5 has a smaller number in the numerator. That makes it less than 1. But if you are more challenged than the average student, then you might have to do something like this. 5 divided by 4. Oh, look, that's 1.25. That's bigger than 1. Whereas 4 divided by 5, that's 0.8. That's less than 1. I'm really hoping you don't have to do that, but I'm a realist. So there you go. Alright, problem number 3. Which of these transformations would map the point -5, 0 onto itself? Okay, So negative 5, 0 has to still end up as negative 5, 0 when we're done. So for starters, if negative 5 is, let's talk about x's and y's. Okay, if negative 5 is going to stay negative 5, that means x definitely has to stay x. Now there is no transformation where we can just say xy stays xy. None of these transformations result in xy. However, 0 is a special case. If you change the sign of 0, negative 0, the opposite of 0 is still 0. So even if y became negative y, 0 would still stay 0. So what transformation is this? And again, I'm hoping this is all in your head, so you don't have to look back at a cheat sheet that you don't have if you're taking a test. But x negative y, you can see that that's what happens when you do a reflection over the x-axis. You get x negative y. Okay, so reflection over the x-axis is the answer, and that's going to be C. Number 4. After a dilation from the origin, point M becomes point M prime. What was the scale factor? Okay, so 6 comma negative 6 became 8 comma negative 8. Now when you do a dilation from the origin, all you do is multiply by the scale factor. So let's call the scale factor k. Alright, I like to use the variable k to represent the scale factor. So when you do a dilation, all you do is you take the original point and you multiply it by the scale factor. Okay, and then that should give you the new point. So just look at the x value, for example. 6 times what value would give you 8? All right, because that's how you do it. You just multiply by k. So 6 times k has to give us 8. But we can solve this little equation. All right, this is not necessarily something you would do in your head, but you can think of it as dividing both sides by 6. That's going to get you k by itself, and then this reduces down to 4 over 3. So that must be the scale factor. The answer is A. Okay, I guess if you were not on that level to where you just visualize multiplying by k and you want to make a little equation, another way you could do it is by trial and error. Alright, if you were doing this problem by trial and error, you would go, okay, let's try 4 over 3. So that would mean I would have to multiply both of these by 4 over 3. So 4 over 3 times 6 and 4 over 3 times negative 6. Alright, and what would that give me? If you were going to do this without a calculator, you would look at these as 6 over 1, and you might say 4 times 6 is 24, and then 3 times 1 is 3, and then same thing over here, but this would be negative 24 over 3. Okay, and that is 8 negative 8. So by multiplying by 4 over 3, we get 8 negative 8, which is what we were shooting for. And then if that one didn't work, you would go and try the next one, and try the next one, and you would keep trying until you found the one that you would multiply by and get 8 negative 8. Alright, of course the way I showed you first is the fastest, is faster than trial and error if you can understand it. Okay, moving on to number 5. Each transformation below is applied to the point negative 3, negative 6. Write the coordinates of the image P prime. Okay, so we're just doing these transformations. So if we reflect across the x-axis, that's the one where the x value stays the same. So it's going to be -3, comma, -6. Okay? And again, we can always refer back to this, x negative y. You can think of it that way. This is your x negative y. So that's what I did. Translate the point 5 right and up 2. Well, 5 to the right, that means adding 5 to the x value. Up 2, that means adding 2 to the y value. So that is going to give us 2, 8. So that's it for B. Dilating by this scale factor. When you dilate, as we discussed on problem number 4, all you do is you multiply, when you dilate from the origin, I should say, all you do is multiply by the scale factor. So if I just take 5/3 and multiply that times -3, and then I take 5/3 and I multiply that by 6, that should give me the image. Okay, so what would that be? So looking at this as -3/1, that's going to give me -15/3, comma 30/3, and that's going to equal -5, comma 10. Alright, so that's the image, -5, comma 10. Alright, clockwise rotation around the origin. When you do a clockwise rotation, 90 degrees, the coordinates switch places. So the point xy will become y, comma, and when you're doing clockwise, it's the x value that changes signs. So again, I'm thinking back to this. 90 degrees clockwise, that's y, -x. They switch places, the x value changes signs. If it was counterclockwise, it would be -yx. Okay, so the y value is 6, that's going to go first. And then the x value is -3, and this negative sign means I need to change the sign, so that's going to become +3. Okay, that's it. So that should be the image. That's number 5. Number 6, draw the image of segment GH after it is translated down 5 units and right 2 units. Okay, so it will be easy to do that one graphically. We're going to go down 5 and right 2. So start with G. Right, so this is at a height of 4. So if I go down 5 and right 2, then this should be G prime right here. And if I go down 5 and right 2, then this should be H prime right here. Alright, I think I will cheat and draw the segment electronically so it's nice and straight. Kabam! Alright, that's how you do that. Pretty straightforward. Number 7. Draw the image of GH after it is reflected across the line y equals x. Now, for most of these problems, there are 2 ways to do it. You can either do it algebraically using the coordinates, or you can do it graphically on the picture. Alright, in this video, I'm probably going to try to show both methods so that my students who prefer to do things algebraically can see how to do it, and if you prefer to do it graphically, you can see how to do it as well. So it's really up to you. So anyway, the original coordinates of point G are, okay, so point G is -2, 4. So -2, 4. And then point H, that's 1, 3. So you could do this algebraically, because when you do a reflection over the line y equals x, then xy becomes yx. Right? Is that not the rule that we have memorized? I think so. So that means we're just switching places. So g prime should simply be 4, -2 as we reverse, and h prime should be 3, 1. So then you just graph them. So 4, -2 would be right here. Okay, so that would be our g prime. And 3, 1 would be right here. And that would be our h prime. Okay, so that's how you would do it algebraically. Now, if you wanted to do it graphically, this is what you would do. The line y equals x is a diagonal line going straight through the origin with a slope of 1, up 1 over 1. Hold on. I'm going to make this blue. Okay, that's the line y equals x. So graphically what you would do is look at point H, and it is diagonally 1 square away from the line. So if I diagonally count 1 square to the opposite side of the line, that's where h prime will be. So there it is. And then looking at point G, if I count diagonally, that's 1, 2, 3 diagonal squares away. So if I continue and count 1, 2, 3 diagonal squares on the other side, there's g prime. So that's how you would have done it graphically. Okay, number 8. Draw the image of GH after it's rotated 90 degrees counterclockwise around the origin. So again, I'm going to do this algebraically and graphically. So algebraically, I start by writing down the original points. Alright, point G being -2, 4, and point H being 1, 3. And then I think about the rule. So we have hopefully memorized that a 90-degree counterclockwise rotation maps x, y onto -y, x. All right, counterclockwise. That's where the y becomes negative. Well, the y changes signs, and the x stays the same. So if I want g prime, I'm just going to apply that rule. So the y will come first, but it will change signs. So that will become a -4. The x will come second, and it does not change signs. And then h prime, the 3 will become a -3 and go first. The 1 will stay a 1. And there it is. So g prime should be at -4, -2. So this should be g prime right here. G prime. And then -3, 1 would be right here. And that's going to be our h prime. Okay, so that's how you would do it algebraically. Now, if you want to do it graphically, here's what you would do. What you do is you draw a path from the center of rotation to the point that you want to rotate, and then you rotate the path. So the center is 0, 0. So if I want to draw a path to point G, that would look like this. You know, I think I need to use a fatter pen for this. Alright, so the path from the origin to point G would be like this. Okay, so that was left 2 and up 4. So I can rotate this pathway 90 degrees counterclockwise. That's counterclockwise is in this direction, the opposite of a clock. Okay, so if I rotate this 90 degrees, this little horizontal 2-piece is going to rotate down and become this vertical 2-piece. And this vertical 4-piece is going to be left facing to the left. Okay, so that's what it would look like if I rotated this path, this arrow, counterclockwise by 90 degrees. And so now this new arrow shows me the location of G prime. So this would be the point G prime right here. And you can see that it is in fact at -4, -2, which is the same thing we got algebraically. So I'm going to have to erase that path because it's in my way, man. In my way. So now I'm going to go to point H. So from the center of rotation, that's over 1 and up 3, there's my path. If I rotate this, again counterclockwise, this little horizontal 1-piece is going to rotate up and become a little vertical 1-piece. And then the little vertical 3-piece is going to become a horizontal 3-piece. And then this new path shows me the location of H prime. Okay, and then I'll just erase those pathways and reveal the image. And again, H prime, -3, 1, -3, 1. It's the same thing we got algebraically. Okay, I think that's enough for one video. Alright, we're at about coming up on 23 minutes. So there is more to come with this lesson. I will finish the rest of this lesson on the next video. Much more to come. So look for the same title, but problems 9 through 15 or whatever it is. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.